Hello everyone, it's February 23rd. Oopsie doozy, we have a hard one today. Alright, I was hoping I have some time to work on this, but turns out we have other things that we need to work on. Alright, let's take a look how difficult this one is. But looking at this 38% passing rate, pretty tough, but it's an old problem, so yeah, I'm not too happy solving old problems. It's just every time you solve old problems and you cannot solve it, and I just feel very dejected. It's like it's a problem you solved before and you couldn't solve it again. But mostly after I solve a problem after like I'll say a week or 2 weeks, I just forgot, and then I have to go back and do it again. It has to go through many rounds of practice in order to memorize how a certain problem is solved. All right, let's see. Find all people with secrets. You'll give an integer n indicating there are n people, number from 0 to n minus 1. You're also given a 0 indexed. 2D array meetings where meetings I indicates the person xi and yi have a meeting at time. A person may attend multiple meetings at the same time. Finally, you're given integer first person. Man, it's maybe like a Google interview. They like to interview with just time intervals. Time intervals. One of the least favorite of my problems. So anyway, we have the two people, x and y, are having a meeting at time I. Okay, person 0 has a secret, and initially shares the secret with the first person at time 0. This secret is then shared every time a meeting takes place with a person that has the secret. More formally, for every meeting, if a person xi has the secret at time I, then they will share the secret with person yi and vice versa. The secrets are shared instantaneously. That is, a person may receive the secret and share it with the person in other meetings within the same time frame. So a person can attend multiple meetings at the same time, so they can share the secret at the same time. Return a list of all the people that have the secret after all the meetings have been placed. You may return the answer in any order. Okay, so let's go through this. Just draw it out. So we have 6 people. So we have 1, 2, 5. So 1 and 2 at time 5. 2, 3, 8. And then 1, 5, 0. Okay, so person 0 has the initial, right? And then person 0 initially shares the person with the first person. So 0 and a 1 already knows the secret, right? 0 and 1 already knows the secret. And then we have 1 connected to 2 at time 5. Okay, so 2 will connect to 3 at time 8. And 1 will also connect to 5 at time 10. Okay, so this is the initial. It smells like union fine, right? So this is a union. 0 and 1 are together. And then we just want to see where does 1 lead to, right? Where does 1 lead to? And then we need to sort this. That's what I feel. We have to sort the time to make sure the timeline works, right? So if we sort this, this is a sorted version. Okay, so probably not this, but we use a sorted version. Okay, so at time 5, 1 and 2 knows, right? So at time 5, 2 gets added. At time 8, 3 gets added. And at time 10, 5 gets added. So everybody's in it. Okay, this is a terrible one. Let's try this. So this we have 3, 1, 3. If we sort it, 0, 3, 3. Oh, sorted, and 1, 2, 2 is the first. So we have 1, 2, 2, 3, 1, 3, and 0, 3, 3. So initial person 3. So we have 0 and 3 in it. And then time 2, nobody. 1 and 2 doesn't know. And at time 3, 1 knows. Okay, that's also not a good example. How about the last one? The last one for 1, 2, 1, 2, 3, 1, and a 3, 4, 2. And initial person is 0, 1. So 0, 1 at time 1, 2 knows. At time 1, 2 already knows, so 3 knows. At time 2, so 4 knows. Wait. Is that just union fine? I feel like it should be more complicated than that. So yeah, at a time, yeah, we try to union the 2. Oh, yeah, if you union the 2, so those 2 are unioned. But if they are not inside, so we keep, yeah, we keep something, yeah, we keep the union. We know one person in the union, right? And then we have, if that person is in the union, then yeah, we union them together. That's fine. The problem is if we take a meeting like here, right? We take a meeting 1, 2. Neither knows, but 1 later knows. So, but 2 still doesn't know, right? 2 still doesn't know. So if I union 1, 2 together, and then later on I union 3, 1 together, then 2 will be pulled in, and that is not correct, right? That is not correct. So so I have the initial pool of whoever knows the secret, right? And then the new one come out, and if neither person is in the initial pool, then nobody knows. Oh, but then we have this scenario, right? Yeah, I can imagine a scenario. Let's say initially 0, 1 knows, and then we have, let's say 2, 3, whatever time, I say 4, okay? And then 2, 1, 4, right? So if I handle this, we say 2, 3 doesn't know. But then I handle this, 2, 1 knows. And since it's instantaneous, so if that happens, right? If that happens, we can actually try this. Plus, this is definitely going to be Python. So in this case, I have 4 people, right? And we have 2, 3 at 4, and a 1, 2 at 4. So this one, everybody should know. The answer should be everybody. I should return something. Right, the answer should be everybody because this happens instantaneously. Yeah, it happens instantaneously. So that's the trick. I mean, since only 2 people, I can definitely check. So that means we need to get at the same time list all the people in it. In this case, 1, 2, 3. You can put a set, right? So at this time I have these people. And the next time I have whatever people. So then when I go through, I check every single one to see if they're in it. As long as one of them is in it, everybody's in it. But then we come a problem. We have to check every single one, right? We have to check every single one. And if you check every single one, we might time out because we don't know. This can be super long. Each one can be super long, right? And then how many times, what's the length of meetings? Meetings can be like this. So we go through 10 to the 5th, and each one you have to go through maybe 10 to the 5th, right? Because you don't know which one is inside. You don't know. And you cannot do the reverse search either because this one can grow. And And we probably need to go from these, right? We probably need to go from, but if you go from these, okay, so yeah, I think that this probably doesn't work, right? We shouldn't sort based on, but we can still produce a graph, right? We produce a graph because it has to start from these two people. So we produce a graph, okay? We produce a graph. And the thing about producing a graph is, like, let's go back to this problem. So we start with 0, 3, right? And from 3, we can go to 1, right, at time 3. And we go to 0 at time 3. And of course, from 0, we also go to 3 at time 3, okay? And then from 1, we go to 3 at time 1, and we go to 2 at a time 2. And from 2, we go to 1 at time 2, right? So this is the graph, right? This is the graph. So now if this is the graph, we start from 0, I can say, okay, 0 will get to 3 at time 3. And so that's just like certain. So 3 will get to 3, I will get to 1 at time 3. And 0 we already handled, right? So it's like, maybe we can just like BFS it, right? So from 0, 3, I go to, but we can set this as a set. So 3 is already in it, we just don't do it. And but the time right now is 3, right? The time now is 3. So because each one has a path, right? So 0, 3 at time 3, but it's already in, so we don't consider this. So this basically 3 can go to 0 already, so 3 can go to 1 at time 3. That's what we say. So when you push into the queue, you have as time, it have like node 1, but time point is 3. You know, it happened at time 3, right? So you go to 1, you have 3, so 3 is already in there, so you don't do. But then you have a 2, right? You can hit a 2. So when you hit a 2, right? When you hit a 2, now the problem of you hitting a 2 is the time is 2. But now your time allowed, so 1 will only know, because we start from the only people who know the secret, right? So as them spreading out, that is the earliest the next person can know. So the earliest that 1 can know is at time point 3. So this is time point 2, right? So the 2 cannot know it from 1, so we cannot add 2 to here. So basically that's just the end, right? That's just the end. So now thinking about this one, so we start from, I think to start from 0 and 1, right? Yeah. So we start from 0 and 1. Okay, we'll start from 0 and 1. And our path is 2 can go to 3 at time 4, right? And 1 at time 4. 3 can go to 2 at time 4, and 1 can go to 2 at time 4. So everybody's at time 4, right? So if I go, 0 doesn't have any. So 1, I go to 2 at time 4. So 2 is added to it. Okay, 2 is added to it. So now we start from 2. 2 can go to 3 at time 4 because it's the same. So 3 gets added, right? 3 gets added, 3, 4. 1 is already in it, so we don't add. So now it's 3 we go to, so that's why. Okay, let's give this a shot. But I feel like there is something wrong with this logic because it feels way too easy, you know? I feel like it's way too easy. I doubt it that it will be correct. But hey, maybe this is correct, but you know, I doubt it. I feel like there might be some edge case I just simply fail to realize. But we can try, right? We can try. So we're gonna go to create a graph first, right? So we say a graph will equal to a default dict. That's not what I want. Okay, that's not what I want. Okay, let's try it again. Graph equal to a default dict. There we go. A default dict of list. Okay, and now we say for x, y, t in meetings, graph x dot append yt. Okay, yt, and of course graph y have dot append xt. Okay, so we go through this. Now we have the graph, and then we shall have the queue. Now the queue is visited. Okay, visited can just be the result. A result equal to a set of 0 and first person. Okay, and then we can say the queue is equal to the same thing, right? So we have 0 at time 0, right? And first person at time 0. So this is that. And now we say while queue temp is equal to a this, and then we say for x, right, and time in queue, right, for each one. Then what we need to do is to check the graph for y, okay, for y and tt, right, in graph x. If y is not in res, which means has not been visited, and tt is that this time is larger or equal to this time, then we say res.add y and temp.append y and tt. So that will go through this, and at the end q equal to temp, and we'll return a list of, I can actually say return any order, so I can do, I feel like everybody is returning in sorted order, so I'll use sorted res just for testing purpose to make sure that we got this one right. So we're gonna run this and see if this is my test case, see if it works. It does work, and I roll these test cases and see if they work. And apparently they works. So I'm gonna try to submit it and see if I got anything right or wrong. I feel like there might be some test cases that I'll fail. So this is a BFS solution, right, where we continue BFS only if the next person has not heard of the secret already, right? Has not heard of the secret already, or right, or the time of her meeting is before, right, before the person that before the meeting time of the person who is passing on the secret. All right, let's see if this one works. So runtime will be O-LAN meetings, because that's the number of edges we'll have to visit, right? Yeah, so OM plus, so I have to go through all the nodes, and for each node, yeah, the worst case we have to go through each node, right? And then each node have to go through each edges, because each node can have multiple edges. But we won't really visit all the edges. But we have to go through all the edges. So I will say OM plus N. That's this. Oh, I'm worried that it might not pass, but we're gonna try. Yep, as I had expected. Too simple a solution doesn't work. That's all right. We can take a look at this. So how much have we done? 44, okay, 44. So we are missing number 4. It's not too bad, 12, so we can probably write it out. Okay, so this is, yeah, we need to figure out like what is actually happening here. The answer is 0, 1, 4, 5, 6, 9, 11. All right, I can debug this, but at the moment I would like to first of all just, you know, play around. Do I have a detailed? I feel like I probably have the exact same problem as before. Okay, so anyway, right, what do we have? I need to, so we have 12 people, right? We have 12 people, and so let's, maybe we should draw it 10 to 8 at times 6, 9 to 5 at time 11, 0 to 5 at time 18, 4 to 5 at time 13, it's 11 to 6, okay, 11 to 6 at time 17, 0 to 11, oh, 0 and 11 can, so let's go 0 and 11, 0 at 11 at time 10, and 11 to 6 at time 17, and 10 and 11, 10 and 11 at time 7, 5 and 8 at time 3, 7 and 6 time 16, 3 and 6, okay, 3 and 6 at time 10, 3 and 11 at time 1, 8 and 3, oh my god, 8 and 3 at time 2, 5 and 0. All right, this is not working. This is not working. We have to debug this. We have to debug this. That's fine. We can debug. I just need to take a look at, so n meetings and first person. Okay. And then this is going to be find all the people, n meetings first person. Okay, so I will do this. I forgot which is the one to debug. Set toggle breakpoint. Okay, and is it F5, right? F5 is the one debug. Yes, Python launch file. What happened? Oh, I went in save it first. Okay, and then F1, F5, Python launch file. All right. That's, oh, actually we don't, this is actually good enough, probably good enough. And I need to have my drawings out. So I need to figure out what actually goes wrong. Let me just create a new page. Okay. So let me move this one a little bit more here so we can take a closer look at the default dict. This is what I'm interested in. Okay, that's what I'm interested in. All right. Okay, and then we start with whom? We start with 0 and 9, right? We start with 0 and 9. This is a starting point. So we have 0 and 9. So of course we try 0, right? So if we try 0, we have 0, we have 5 at 18, time 18, 11 at time 10, then 5 at time 7, and 11 at time 20. Ah, that's the problem. We have a duplicate here, which means I shall ignore this and pick this. Holy crap. Okay, right, so if we pick this, we're at 9. So for 9, we have 5 at 11, which is also, right, 5 at 11, also ignore because earliest is 7. And then 1 at 4, right, 1 at 4. So that should be the next round. So now we are at 11. So of course, when we do this, we'll add 11, 5, 11 again. So this one is also removed, and 1, okay? So next round is 11. So 11 comes out, we have 6 at 17, okay? And 0 at 10, 0 is already in it. 10 at 7, okay, 10 at 7, 3 at 1, and 0 at something, right? So 0 at something, 0 at 20, we don't have zeros already in it, right? Next is 5, so 5, we have 9 at 11, 9 is already in it, 0 in it, 4, okay, 4 at 13, 8 at 3, 0 at 7, okay. That's 5. Next is 1. 1 is here. 1 is only 9. 9 is already in it. Okay, so that's that. Right, so we are adding now we have to check. Oh, we have to check. So this is 11:10, right? It's the earliest. So I didn't check that. 11:10. We added this, so this is no good because no, this is good. This is good. My bad. This is good. This is good. So 6, 11 is good, and then 10:7. 10:7 is no good because this happened at 10. So 10:7 is no good, right? And then 3:1. 3:1 is no good. Now 5:7. 5:7. We have 4. 4 is good. And then 8. 8 is no good. So basically next one goal is only this and this, right? So I have 6. 6, if we go 6, we have 11. We hit it 7. Okay, so we have 7, 16. Can we go 7, 16? We can because 6 is 17. So 7, 16 cannot go. 3:10. 3:10 cannot go. So this one is done. So 4. 4 is 5. So we're done. So this is my answer. This is my answer. 0, 1, 4, 5, 6, 9, 11. Yep. Okay, I think I know what went wrong. Let me quit this. So what went wrong is I did not do this overlapping thing, which means during this, it has to be a little bit more complicated. Okay, it has to be a little bit more complicated, which means we probably shouldn't use this data structure. What we should use is a different data structure. Dictionary will be the best bet, right? So I'm going to use a dictionary, 0 at time 0 and first person at time 0. Okay, so that is also going to be a dictionary. And what we're going to do is for x and t in q dot items, right? So we do this items, and then for this it's fine. If y is not in res and tt, which is the time, if it's larger or equal to t, then res dot add, that is fine, but this is going to be different. This is going to be temp, we'll put y, right? Because we want to, so equal to minimum, minimum temp dot get y0, right? And oh, you might have to, you can use a default dict. Actually, no, we want the smallest, so this is actually not 0. This should be math.inf, right? And the current TT, right? That's that. So blah blah, when you're done, then you do this. All right, what is the type for this? The type for this is dict of int and int. Oh, really? Yep. Oh, really? Math of this. Okay, what's the maximum value that can be picked in this case? The max value that you can pick is 10 to the 5th. Okay, 10 to the 5th. So the max, this is 10 to the 5th. So 10 to the 5th. I might as well just set a max. Okay, so I can set a max equals to 10 to the 5th plus 1. Right, that's definitely max. So I can go here, I can just call this max. Right, and then at the end, we do this. I mean, obviously we don't need to sort. I can just do a list. That will work as well. Okay, let's try this again. See if this one holds. Actually, I like this, so I'm going to paste it here and try one more time. Okay, so first of all, I need to make sure these are all still correct. Okay, they're still correct. Then I'm gonna try this, put it at the bottom, and then run it. Hopefully this one is also correct, but is not correct. Okay, that is very, very concerning, because I ran the 4 is still not in there. That is very interesting. What did I do wrong? Yeah, you check the graph. Okay, I get y if it's not in, and the current time is larger or equal to the previous time. Then I add it to it, and my temp, right? The temp is the next one, which is gonna be getting the minimum of whatever it is, the y, and the smallest time. Okay, this one deserves a debugger, because I tried this and everything works. 4 is included, right? 4 is included, and 4 is included. I don't know why. That's fine. You can just run it, right? Run it, and I think we have if1. I actually don't remember which one is which. Oh, that is not. Wait, hold on. When we just run? Oh, damn it. That's not right. F5 again. All right, we just do this. Wait, what? What? Huh? Wait, what the hell? I set a breakpoint, but why is it not working for me? Why did it just jump here? Hold on, something is not right. I'm not sure. Do I have to put my cursor here as well? Well, I think I did not save. That's also an issue. Okay, let's see. Yeah, I'm pointing here. That is correct. Then there we go. Now we're right. Okay, so result is 0.9. That's cool. And do this. Q temp. Okay, for xt in Q, so x is 0 and t is 0. That's good. And for y, in what 0 connects to? Okay, who does 0 connects to? 0 connects to. So 518. That's the first one come out. Right. 518. Good. And then rest plus no, I have 5 added, and temp. 5 is 18. Okay, next one is 1110, right? So 518, 1110, 57, 1120. Okay, so 1110 also we added to it, so we have 1110. Now next one 57. So I shall see this 18 turns into 7. Oh, now I see. Holy shit. Okay. Yeah. It was not right. So okay, so this is if TT is larger than, right? If the time is smaller, definitely cannot do. And you can definitely add this, right? You can definitely add this. This is fine, right? This is fine. But here what you need to do is to get the time. Yeah, maybe this is it, right? Even if you visited it before, right? You visited it before, but then your time is now small. Actually, no. It's only if your time is smaller than. Okay, so it is if you have not been there before, then you definitely add it, right? But if you are there already, and in fact, you can always rest can add, right? It's a temp, right? If it's a temp, if you are no, because the time only goes up, right? The time is only go up. So if you have something that visited before, then you definitely shouldn't visit it again, right? You shouldn't. That is the thing, right? That is the thing. So I don't think you should put the rest right here, right? You put the rest right here, it's really hard to discern. So if you don't put the rest here, you put the rest earlier. Okay, you put the rest earlier, and then you let the temp to handle. Okay, you let the temp to handle, which means yeah, so like whether you're in the rest is irrelevant, right? It's irrelevant. Okay, it will be like this. Okay, I added here. So rest dot add x, we put it here, and then this is still if y is not in rest and we don't do this. Okay, so if it has not been visited, I just keep going with this. So if I run this and I just go run it, and we just run it, it will pass, right? It will pass. Okay. So I'll try it again one more time. Right, then I'll definitely try the other one as well. Use the template, go everything, and try it again. Yeah, we add the result at the end. We don't add it inside. So we can use this to weed it out and use this to keep track of the stuff. All right, I'm gonna run it again. And it was wrong again. I think I'm repeating the same process as before. Hey, how are you? Look at this. I'm repeating the same thing as before. I got one bug and now I got another bug, and this one is definitely not debuggable. Okay? This is not debuggable. What a mess. What a mess. All right, what else did you not consider? Dear me. This is not debuggable, man. Did I also miss another? Did I miss something again? Let's see. Yeah, you're missing a lot of stuff. Yeah, you're missing a lot of stuff. I'm doing all right, but I'm getting stuck again. Look, this is an old problem. Solved it before, but spent a lot of time on it. Really a lot of time on it, and having trouble again. And I don't know where the problem is. So in this case, usually what I do is I reduce the number of cases, or we just reduce it and see if I can still produce an error. Hopefully I can still produce an error. So if I can produce an error, that means, okay, I think I cut it down a little. Hopefully it's still errored out. Ah, shoot. So this is not working. Yes, I did say adios. Well, that was not the first word I learned in Spanish. Okay, so now this one is error. That's good. That's good. So we cut it down a little bit. Oh, but we need to cut down even more. Damn it. This is not going to work. I'm going to try maybe a few more times. Oh, this one's correct. Shoot. Okay, let's delete the earlier part. So maybe I delete the earlier part. Hopefully this one will give me an error. Come on, give me an error. Oh my god, it's also correct. See, this is tough. I have to pick something in the middle. Man, this is not working. Man, this is not working. This is not working. I can't keep doing this. I have to figure out where I got it wrong. Yeah, this is not working. I have to figure out where I got it wrong. What do you think? I mean, the logic is sound, but I'm missing. Okay, I'm missing 17. Okay, so maybe we can check where is 17. Let's see, like, where do 17 get its connection? And then we start from where? We start from 125. Jesus. We start from 125. All right. No fear. Let's just give this a shot. Okay, we're gonna give this a shot. We'll give this a shot. That's okay. That's okay. I'll give this a shot. And 67. Oh, what happened? 5. Go to the front. And then we need the answer. What is the answer for this one? And expected is this. Okay, let's save this. My God. 610 lines. That's... Okay, let's try. We're gonna do F5 and run this. Just want to take a look. So our target is 17 because that's the one we didn't get. Okay, so we target 17 and we'll see. Oh my God, that's a long list. So we start first person 125 and where is 17? Why are you not sorted? Shoot. Where is 17? I don't know where 17 is. It's hard to find 17. Oh, hold on. I can find 17. I can do 17. Okay. What's the next? This is not working. Hold a second. Let me go to the front. Oh, this is 17. Okay. This is 17. I don't think this is gonna work. I do not have Discord channel. I don't do social media very much. I basically don't do social media actually. So 125. Okay, let's go 125. I just need to see. Okay, that's a 0, right? 0. I have bunch. Hold on. Maybe we can just investigate. Oh my God, this is gonna be a terrible journey. So we start from 0 and 125, right? That's our starting point. Just double check if it's 125. What is it? Yeah, we start from 0 and 125. So from 0 I can go 125. Okay, so from 0 I go to 90, 144, right? And then 78, 282, 125. So this is where it's the print debugging might be a little bit more useful. 19. Did I have 19? Did I get 19? All right, the question number is 2092. 2092. I use WeChat just with my parents. Don't do much WeChat either. Okay, did I have 19 for this one? I did 19. But 17. Oh, this debugging is not gonna work, man. I just wonder, like 17. I have these times. It's something go to 17, right? It's something go to 17. So I need to know who goes to 17. But right now I have 90, 70, 78, 125. You know what? Maybe what I can do. There's a step. Okay, maybe I should put. Hold on. Let me terminate this. If I put the breakpoint, I don't put the breakpoint here. I put the breakpoint here. Okay. If I put the breakpoint here, can I just, go to the next one faster. Can I just it's this one? No. Step out? I think it's step out, right? Yes, step out. So this is after first round, right? This is after first round. I have all of these in it. Okay. And then and these are all in it. Again, like how do you? Okay. No, this is not gonna work. This is not going to work. I will have to cancel this. This requires a print debugging, right? So what I need to know is whenever y is equal to 17, okay, if y is equal to 17, because that's what I want, and we need to print, okay, when the print debugging, what I need to know is x and t, okay, and it's the current tt, right? So, and then I'm gonna run what's today? Today is 24th, right? So the first time I hit is 96, right? The first time I hit is 96. That one didn't work because the time is earlier, and I hit this, didn't work. Yeah, none of these work. None of these. How does 17 get incorporated? Right? Seriously, how does 17 get incorporated? Which just means this logic is not right. This logic is not right. Maybe what happens is, but 17 has to be in contact with these numbers, right? So 17 has to be in contact with these numbers. Yeah. So they know the secret later than the meeting with 17. But what might happen is, when does these people first learn it? I think I know. So these are the time. Oh, we need to modify this time as well. Holy crap, we need another one to record when is the first time. Okay, yes. So what happens is, I'm using the graph. Wait, hold on. These x and t is from this q, right? It's from the q. And what I need is the earliest time that a person knows the secret, right? The earliest time that a person knows the secret. So I want another one. So the earliest time that a person knows the secret shall be a dictionary of 0 is at 0, first person is at 0, right? And then the q can be just the q, right? I think in this case a q can just be a q. I don't have to be anything special for this. And then we go through the q as usual, right? And I don't need to keep this time because we're not doing time here. You can add this, that's perfectly fine. And then for this, I don't need this. Then we say if y is not in the rest, okay, and the current tt is larger than the earliest time, which is your earliest time. Oh, that is not the naming. That's not the naming convention. It should be a snake case, right? Underscore t. So what we say is if tt is larger or equal to earliest time, your x, So this is the earliest time. So this should be the earliest time that a person learns about the secret, right? So if the current time is larger than the earliest time, then we shall do it, right? Then we shall do temp, right? Temp dot append y. And of course here we need to change to temp is equal to this, right? And then q equal to, and then we do this. And this max is never used because I need to update the earliest time as well, right? So I do this and then I just say earliest time. Then why do you need res? You don't need res, right? I don't need this. You don't need this. Let me think. Because what I was thinking is you can do earliest time, right? It's earliest time, but y is not in res. So I can say y is not in earliest time. But what if the current time is smaller? Right? What if the current time is hold on, let me, I think I'm very close. I'm very close. So y is not in res, right? And it's current time. So if y is in res, then we don't do it. But if we don't use res, I shall say if y is not in the earliest time, right? We definitely do it. And if y is in earliest time, but the current time make it better, I shall just update the time, right? I shall just update the time. But that is not right. I should, right? I should make the time, right, but I don't go through it again, right? I don't go through it again. So if I have got it in, right, then it doesn't really matter. If y is not in this, or y is in this, but the current time is, okay, yeah. I think I'll do something like this. If y is not in earliest time, or TT, so y is in earliest time, but TT is smaller than, right? TT is smaller than, but we don't put in the temp, right? We don't put in the temp. If y is not in earliest time, then we definitely do it. If y is in earliest time, then we need to check if we get a smaller time, right? If we get a smaller time, then we do it. But we still, okay, so it will be like this. Okay, if okay, how about this? This is still work, right? If y is not in earliest time and the tt is larger than this, we do earliest time y equals tt and do this. Else, okay, else if y is in earliest time, right? Then all I do is earliest time y shall equal to the minimum of earliest time y and the tt. That's that. And at the end we return earliest time of keys. Yeah, I didn't use the max at all, so I can delete this. Let's see if this one is right. First of all, we're gonna run our test cases here. Okay, then we're gonna run this bad boy. I probably should also run this bad boy as well. Okay, so just two complicated test cases. All right, let's see if they both work. Ugh, that do not work. Shoot. Shoot. Why in earliest time? So which one? Which one failed? Is this one failed? Oh my god, it's the same one failed. So how does it fail look like? Oh, I'm missing two. Different type of missing. Oh, it's not missing. I'm adding more. Oh, this solution I'm adding more than I should. Holy crap. Huh. How? I need to know the earliest time that a person knows the secret, right? So if y is not in the earliest time, and if the current time is larger than the person currently, right? So for x in q, for y tt in, and then I check earliest time, so x is 0, so okay, the earliest time y gets to know is this time, right? It's the earliest time y gets to know, and I put y, okay? And then if I have another one, y it's already in earliest time, then I just check to see if the current tt can be even earlier. I think it should be like this. If tt is larger than, then I say if this, I put it in, and else I try this. How about this one? Pending. Okay, I cannot wait for you forever. Okay, so I'm gonna try run it myself. No. Yeah, still fail. What did I got wrong? Come on. Still right. And this one is still wrong, right? I already... Ouch. What the hell? Yep, I'm back to the missing. I'm back to missing. How? I'm always keeping earliest time as the earliest, right? Why TT in graph is Y and TT is the meeting time. I say if this meeting time is, if this meeting time is smaller than the earliest time that X can have. Okay, so what might happen is X might have an earlier time later on, right? X might have an earliest time later on. That's actually possible. Okay, hold on, let me grab some snack. X might have an earlier time later on, which means when 1 is hit right now, X doesn't have, okay? But later on, X might. How do I reconcile that? But you can't, can it? Because the time always going bigger. Alright, I go to some meetings and then it has some people at a certain time, and then I go to another meeting. If this TT what might happen is at current level, I need to get them the smallest time come out earlier. Which means gonna sort them. Maybe. And then just sort them. How would that help? No, I'm imagining why the 17, 18 is not included. So what I think is, right when we hit 17, we're at a time. It's just not the earliest time, right? It's always earlier than the earliest time for the others. Maybe later on, through some other means, the others is actually at an earlier time. Yeah, right? Yeah, I think that's the problem. When 17 has hit with some other people, the meeting time is earlier than right now. We know the other person gets to know. But if moving on, the other person's time gets earlier and earlier, might get earlier, right? But why would the other person's time get earlier? Because through a different route. Damn. Through a different route. Which means if a person gets an earlier time, we should put that in as well. Okay. What I'm saying is, L TT is smaller than earliest time, Y. So the current time is smaller than whatever it was there before. Then, not only do I record it, but I also do it one more time. This will make it run more than this, so I actually don't know about the runtime. I actually don't know about the runtime now. But anyway, let's try this one. There we go. There we go. Yep. So this is a fresh, right? Y knows the secret for the first time. This is Y knows the secret earlier. So when it knows earlier, you have to keep going, right? Note that if a person is able to get an earlier time of knowing the secret, we have to put him, her back in the BFSQ because learning the secret earlier can affect all the children connected to that person. All right, so I'm gonna do kind of a final round of testing. So I will use this. And if this is good, we're gonna submit again. Okay, submit again. Yep. Nice. 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 1 hour 15 minutes. I'm happy. Very happy. And 1 fewer attempts than last time. I'll go through 2. Last time I had to go through this. And it was fast. I don't know what to say about this. This is because we have to reinsert it into it, depending on how many times, right? So time complexity is really a toss. I have no clue. I don't even want to know. You know, I don't even want to know. Okay, I am curious about my solution before, so I will take a look. Oh my. Oh my. I was using DSU last time. Detach. Wow. Okay. We set 0 as the ultimate parent. Union looks about the same. Detach X from any group it might have been associated with. So we sort based on time. Okay. We union this. Okay. If T is not equal to pre-T, for P in people, I go through all the people. Now say if parent not 0, I'll detach it. And we reset people. What? And we union. Pre-T equal to T. What is this people? I think this people is people without secrets. No. People is the one without secret. Yeah. Basically says we'll go through everything. We first remove all the people without secrets. And then we union X and Y. We just union X and Y, right? And then X, Y is people without secret. So next round, just in case, yeah, we remove those. Okay. Yeah, but this is so much slower than what we have here. The BFS solution, much faster. BFS. Yep, earliest, you have to have this. Earliest next person. Slightly different. You don't. This one doesn't check the earliest current person. It checked the earliest next person. I don't know why. Right? It checked the next person. So T, time and next person. Time. Oh, they do have the time. They check the time here. This is the same as this. Yep. I see, because I can simply do can do earliest, right? Earliest time equal to default dict lambda math.inf. All right, and then I can do earliest time 0 is equal to 0. Earliest time first person equal to 0. And then as we go through, if this is this and tt is smaller than earliest time y, because I have a default value, right? I have a default value, so or knows earlier. At an earlier time. These two are exactly the same. I save a few lines. If I run this, of course I can just do list. Person. I don't think this will be even faster, but we can You can try. Yeah. It's all right. Call it solution 1. Oh, no. Oh, wait, what the hell? D6. So same idea as above, but with better implementation. Oh boy, this is great. So what's the runtime for this? M times n plus n. Okay, yeah, I can do that because I know it's m plus n for the BFS, and within it you have to add the same thing again, right? Because the nodes are not visited once, so the nodes has to be added again. That's actually not what it's saying. So the meetings, okay, take m times. Earliest array. Yeah, this is my thing. Yeah, that's fine. The while loop. This is the thing, the while loop. And most m neighbors. How many times while loop run? Yeah. How many times while loop run? And most, that's not true because some people can be in queued twice. That's the thing. Some people can be queued twice. So that's why I think the time complexity is really hard in this one. In each iteration, one person's process. The person was in queue because of meeting with some other person. Hence, there will be at most m plus n iterations of the while loop. Thus, the while loop takes this amount of time. I'm considering from a different perspective about yeah, I probably shouldn't consider from. So for x in q, right, and then for y in this, that's m plus n. And then we go through how many rounds. I don't know. All right, I'm not gonna just dwell on this. Yeah, I'll just call it a day. All right, that'll be it. That'll be it for today. Good problem, right? Very good problem. I think last time I solved it by myself as well, but I was able to come up with a better solution today. So very happy, very happy. All right,